We are discussing about the blast results. We have seen that there are three formats which are available for blast result. One is graphic summary, one is description, and the third one was alignment. All the three results are actually same but represented in different way. We were discussing, we have to discuss about the graphic summary first. In the graphic summary, the first section is actually what the conserved domain database based alignment results, on the basis of which we can do domain predictions for my query. Okay, how we are going to do that? I told you that the first line is your sequence. The numbers are the positions of the amino acids. Specific hits are available and families are available. So based on that, there is one domain which has been predicted, that darker green arrow which you can see. Yes, throughout. So this is predicted on the basis of IIGF insulin-like family. So based on the alignment of your query with this family, the domain has been predicted. Secondly, it also tells you that your protein also falls into the superfamily of IIGF like superfamily. Okay, so you can study these two families in the conserved domain database in order to understand what kind of characteristics your protein may have. Okay, because I am considering that I do not know anything about insulin. I am considering insulin as a new subject for me. Okay, forgetting that every data is available, most of the data is available rather. Okay, there is one more line over here where you can see triangular peaks are there. Yeah, and they are mentioned as putative receptor binding surface. Putative receptor binding surface. Now, these putative receptor binding surface is what? The binding surface is present in your protein as predicted. These peaks, which you can see, they are pointing towards a residue, right? G, L, E, and Y. So these are the binding residues. And if you can understand, your binding residues are never single residues. They always and always refer to the pocket containing the residues. Okay, so these are the prime residues. So in order to know which is the pocket, you have to find out the pocket in which all the residues are present. Okay, so your docking studies, if you do not have anything, this is one way of finding out the binding surfaces in your protein. Yeah, okay. Now let us talk about the later section, which is the graphical representation in form of alignments. Okay, now the green line which I can see now where query is written, yeah, the correct. Okay, the green line, where is your cursor? No, not this one, the one, yeah, the query. Okay, now this query is actually your insulin. Okay, and you can see the numbering is also like this. If your query would have been 200, 300 in length, then obviously the length won't increase here, the graph does not increase, the marks of position will be increasing. Okay, so it will not show you 100, it will show you 200, something like that. Okay, now there is a scale. No, you're moving your cursor wrong. Move your cursor to the bottom graph.
This one, okay.
Yeah, okay. So this 1, 20, 40, 60, this is what I'm talking about. Okay. Then you can see there are certain blocks, colorful blocks, black, blue, green, pink, and red. So these are the blocks which you can see, blocks, not lines, just above the, yeah. So these are the blocks which are showing you the scores. Like I said that higher the score of alignment, better will be the confidence on the kind of predictions we can make. Okay. So it is given to you that if it is red in color, if the result shows you red, it means that the score of the alignment is more than 200. Right. Or equal to. So it means that if I receive more of black or blue, what does it mean? It means that the alignment is of bad quality, because then the score would be less than 40 or between 40 and 50, which is bad as compared to the higher score of 200 and more than that. Right. Now let us see the result. The result is actually these lines which you can see just below, the red, the pink. Each line here represents one protein sequence. If you move your cursor, yeah, you see that the first line is Homo sapien insulin synthetic construct. If you move your cursor on the second, you will be able to see the other sequences. It is insulin pre-protein. So each line represents a specific protein taken from the database and arranged in such a way that the best results are on the top and the bad results are going below. Okay, so these are the top results which have been shown to you from BLAST. Now each of these lines, if you click on any of the lines, yeah, when you click on these lines, they give you a small description stating what is the score of alignment, what is the e-value, what is accession, what is alignment and all. Okay, you can also take the data from here. Supposingly, I know that whatever I have clicked right now, it was red in color. That means it is having the best score. I picked it from the top results and it is having the red score. So this means that this is a good data from where I should predict the data, right? Supposingly there is one red line, one is black line. Obviously, what will be your preference? The red line, because the score is quite high in that case. So I have also picked up one line like that. Now, if I want to see the alignment, okay, let's see the alignment first. So click on the alignment which is written here. The moment you click on the alignment, it will direct you to the alignment between the query and the sequence you have picked up. So this is the sequence which you have picked up. Okay. Yes. Okay. Whatever you click, the first result on the screen is the result. You can see there are two results shown to you, but the top one is the one which you have clicked. That you can verify with the query and the accession also given to you. Now let us understand the alignment over here. Yes. So it is written query 1 and the sequence is written, then 60 is written. Then second line may some sequences are written. Third line may the subject 1 sequence and 60 is written. Okay. Similarly, the next page tells you query 61 and so on. I think you can figure out what are these numbers written after query and subject. This is showing you the positions of alignments. It shows you that the query ka first amino acid is aligning with the first amino acid of the subject. Similarly, since they are not showing you the sequence in one line, they have just broken the sequence after 60 and shown you the result of 61 onwards in the second line. That is the number which they are showing you. Now let us understand how the alignments can be analyzed. I told you that every tool has their own descriptors. So BLAST also has its own. So yesterday we have discussed about the descriptors used by Cluster. So what about BLAST? Now BLAST gives you two types of results, similarity and identity. Identity is represented by alphabets. So the middle line which you see, yeah. Okay, this middle line is actually the result line. Okay, if in the middle line alphabet is written, it means that it is identity. Okay, and if there is a plus sign, it means that it is similarity. Okay, so you see that throughout the first result, the result shows you all the alphabets only. This means that there is an identity throughout the sequence of query and the subject. And that is very much evident. As you can see, the top shows you 100% identity also. So definitely the sequence is identical to your query. Now you have to study about this particular thing. Now if you see the organism description, it is Homo sapiens insulin synthetic construct. So what does this mean? You are having 100% coverage. You are having 100% identity. What does this mean? It means that this is the query of your interest only. So this result is actually showing you the alignment between the query and query only. But since your query is not a novel query, that is why you can find the same query in the database. Okay, it is just like that. If I compare me with me, what will happen? I will get 100% coverage and 100% identity, right?
Yes.
Yeah. So this means that if I would have to extrapolate, so this is a very good data, I can extrapolate. But what is the point? If this means that I am picking up the sequence from here to extrapolate the data, it means that I have not done the literature properly. Okay, because if I would have done the literature properly, then I know that the data is available for insulin in the databases, right? But I considered that insulin is a novel query. So in this condition, I can say that, okay, this is something which I have got the closest to my query. Okay. Now, similarly, the second sequence, similarly, the third sequence, and so on. If you just scroll down, stop. Yeah, just hold. So yeah, just hold for the Pongo abili, that species which you can see. There is a gap in the result. The first line, the gap is zero.
0.
No, in the alignment.
Achha,
Yeah. Now this gap is actually, we don't say that this is a gap in the alignment. The gap in the alignment which we used to say, like the numbers, the statistics shows you there is zero gap. Obviously, this is the result. This means that there is no relationship which could be established between A and Q. Neither it is identity, neither it is similarity. That is why they have written nothing. Okay. So since it's a local alignment, so basically the BLAST tries not to throw multiple gaps or many gaps in order to just to attain the alignments, because they could find that all the other alignment was so nicely done. You can see that there are 109 identities out of 110, right? So that is why they have not thrown a gap and just disturbing the entire alignment. They've just shown no result for A and Q. Okay. But if there is a gap in the subject, if that shows you actual gaps, and the statistics will also be changing in that case, because that means that for alignment they have thrown a gap, and for that residue you cannot predict anything. Let's see if we can get it from here. Scroll down. Can you stop for a while, please? Scroll up. Stop. You're moving too fast. Scroll down. Stop. A little more down. No. Just see that if you can find a plus sign. Scroll up. There was a plus sign on the top, I think. Yeah, hold. Pan. Yeah. So you see there is a plus sign. This plus sign is a symbol for similarity. Okay. So identity is represented by alphabet. Similarity is represented by plus sign. Okay. Okay. Now one more thing you need to observe over here is that here you see query is written 1 till 60. Subject is written 95. Can you tell me why?
Because the alignment, the 95th residue is aligning with the first
Yes.
residue of the
This
sequence.
means that this, whatever the subject is, the pan species, insulin, isoform, whatever they have used as a subject, they have not aligned the first amino acid of that subject with the query. It is the 95th amino acid which is aligning with the first amino acid of my query. So I'm not interested in the whole part of the pan species insulin, but I'm interested only from 95 to 204, which is showing you 108 identical amino acids. So basically 98% identity is there. Okay. So I wanted to show you a little gap actually. So the gap I want to show you, scroll down. Let's see if we can find some gap. So the reason insulin is very good, yeah, okay. You can see that E ke aage there is a gap written, right? Yeah, so these are the gaps in the subject. What does this mean? This means that I will not get anything in reference to DLQ. DLQ के लिए we have gaps, right? Which means that I won't be able to predict anything for that. Although this is a very small part, okay? These gaps are something which does not bother much, okay? But if this gap increases, then that is bad. Now in the next, you can see that there are gaps in the query. So this does not matter much. Why? Because I am not interested in finding the data for the subject. My focus is on query extrapolate, query ka data extrapolate karna, right? For that I have the information. If the gap is in query, it does not bother me. Why? Because it is having nothing to explore, right? They have just thrown the gap to get the alignment. So this 1 2 3 so on the continuation, you see that even it is not 60, it is 56 because they have thrown the gap in middle, right? But that does not matter to me. Why? Because I don't have anything to worry about those gaps, because I am here to predict the data for the subject, not the query. Okay, fine. Okay, now coming back to the top. So in short, the alignment is supposed to be studied with plus sign, alphabets, and look out for the gaps. Gaps should not be there in the subject. Gaps in the query does not bother me much. Okay, but you will do the alignment for which queries? The ones which are showing you good scores. That means the red lines will be the lines of my interest. Okay, make sure that if you're studying about human insulin, the first line which was human insulin only, they would be of no use for me. Okay, so you scroll down the lines representing other than the human, so that you can extrapolate the data from there. Okay, scroll, scroll. Now let us see that what is the description. Okay,
Ma'am, this red line is not like for us. What does it mean, ma'am? The first red line.
because that is the query line only. They have aligned the query with the query, because your query is not novel, right? It was there in the database, so they have aligned it with the query only. So just like supposingly, if I want to align myself with the database of people in RASA, so in the database, Sakshi ka data will also be there, right? Correct? So if I said
Yes, ma'am.
that I am unknown, but my data is already available in the database of RASA, obviously I will get 100% query coverage, 100% identity. So if I would have known the data in the starting, why would I do the blast? I considered that insulin is a novel subject, right? This is something which I would have studied. The insulin of Homo sapiens I would have studied
Yes, ma'am.
from Uniprot or NCBI, any other source,
Ma'am,
right?
a sign, if it is there, like rather than a digit, then what it symbolizes, ma'am?
Sorry,
Ma'am, if plus sign is there rather than alphabet in the sequence.
that is similarity.
Okay, ma'am. Thank you, ma'am.
Yeah. Okay. Now here you can see, here you can see the table. Okay. Now this is the same thing. What we have seen in the lines, graphical lines, what we have seen in the alignment, the same thing is represented, just that we are getting the values here. Okay. So this is in the same sequence of those lines. This is in the same sequence like the alignment is shown to you. So you see the first line is what? Homo sapiens insulin synthetic construct. Second is pre-protein and all. Third is Pongo. Fourth is INS and all. So you see that we are getting the same sequence. Okay. Now let us see that what are the columns and the values. The first one is the maximum score. Second is the total score. Okay. Now if you say what is this, these two scores are basically what? Supposingly I give you a question paper which is of 100 marks. Okay. And you obtained 80. So 100 marks is total score and maximum score is 80. That means the alignment between the query and the sequences shown to you, maximum score means what you have got, what is the alignment score, and total score means if it would have been the perfect alignment, what can be the possible score. Okay. So if there is too much difference between the total score and the maximum score, then that is also bad. Okay, am I clear?
Yes, ma'am.
Okay, because you see, supposingly the total score is 500, supposingly, okay, and the maximum score is 224. Still, it will show you red color in the graphical. Why? Because the score is based on that only. That every time the score is more than 200, it will show you red color. But you see that you could have, it is just like half of the 50% you can say that you have achieved in the scoring. So that is why you should see that your maximum score should be closest towards the total score. Okay. Okay. Now query coverage. When you talk about query coverage, what does it means? Exactly how many number of amino acids are aligning, excluding the gaps. So it is 100% for our first case, second 100, third 100. So third is also 100. What does it mean? It means that your all 110 amino acids are aligning with Pongo species. First two is something which I'm not interested in right now because they are the same sequences of my query. So if I have to extrapolate the data, I'll try to extrapolate it from Pongo. Okay. So here I'm getting 100% query coverage. Talking about e-value. E-value is actually what? Expected value. So it shows you number of hits you get after sequence alignment such that they have similar scores. Okay. If I tell you in simple language, I would say that supposedly I'm aligning me with you all. And I found that Shreya is having a score of 10. Okay. And Megha is having a score of 10. What does this mean? It means that there are two more people, there are one more people. If I talk about Shreya, then Shreya ka expected value will be 1. Why? Because there is one more person having the same score with the query, which is Megha, right? Similarly, the E value represents the same. That means how many number of hits you can get having the same or similar score. Okay.
Okay.
So this means that if your query and the subject shares E value closest to the 0, okay, it means that the data will be more significant because no other sequences are having the similar scores. So that will be more significant data. So using E value, we try to find out the significance of a data. Closer to 0, more significant. Going away from the 0 means alignment is there, but there are other results as well or other hits as well having similar kind of scores. Okay, so E value helps you to find out significant data. Percentage identity, you know how many amino acids are identical in percentage, that is what your percentage identity. Accession is basically what? The IDs. So if you want to, if you see that the third result is very much important for you and you can extrapolate the data from there, then you can use the accession and you can read the data of the accession which is given to you and you can extrapolate it for your query as well based on the alignment. Okay, this is your NCBI accession, XP, AKI, NP and all. Okay, so these are your expressions. If you scroll down, you may find some other also. Scroll. Yeah, you see that this is what uniprot ID is also there. Okay, so this is an NR database. That is why you see that all kind of IDs are given to you. Okay, now this is what your alignment is. And if I have to, if I say that, if my query is now, if I give you a query and say that, give me 5 homologous sequences for human insulin except for Homo sapiens. What will you do and which one you will pick? Yes, guys. 5 homologous sequences for Homo sapiens insulin. Okay, so one she has picked up Pongo.
I don't know the species, the organism.
Okay, yeah, we can skip that then.
So that's why I haven't.
So why you haven't picked up pan peniscus insulin?
Because I've already picked up one from.
Pan, that is different. Pan,
Okay, yeah.
yeah, that is different, right? No, you're still missing. Pan trog is different. Pan peniscus is also there. Yeah. Okay. Okay. Now, why you have picked up these?
Because they show good query coverage, good